is an M flight connections. Your task is to check if you can travel from any city to any other city using the available flights. Okay, that means I'm given a graph kind of thing. I need to check if I can travel from any city to any other city using the available flights. Okay, the number of cities and flights, the city. There are M lines describing each cell is the 20 and there is a flight from city A to city B. All the flight. Okay, so it is a directed graph. Because that makes sense, because otherwise it's just, so if it is not a directed graph, then we need to just perform a DFS, which will tell me that there is only one component, is one island, right? But it is directed, so I need to travel from any city to any other city. So is it a strongly connected component? Yeah, then only if it is a strongly connected component, then only it is possible to go from any city to any other city. So how to find the strongly connected component, the number of strongly connected components in this graph? I think Kosaraju. Okay, so how do we write it? Let me think about Kosaraju. So I have, let's say this is the graph. So this is the compressed graph, let's say. After finding, no, let's say this is the original graph. So what are all the connected components of this graph? So everything is a connected component, right? No. So can I go from this node to any other node? No. So this is a connected component, this is second connected component, 3, 4, 5. I think, yeah, get the order, reverse the graph, and run the, so I need to get 1. Okay, so when will I get 1? If and only if I start my DFS from here. So that means this order vector should give me 1, 2, 3, 4, 5 for this graph. That means, yeah, topological sort, find the topo sort and find the topo sort of this graph. That will give me the order, one possible order, and reverse that. No, why to reverse? So the topological sort will be this one only. First do 1, then 2, then 3, then 4. Then run from 1 till n, run DFS on the reversed graph. So we need to create both the graphs at once. Let's write the code. I think we would need one adjacency of max and one reverse adjacency. Okay, the number of cities and the flights. All the flights are one-way flights. Yes, no. Okay, so M. So let's read N. M. First line contain N and M. We can read there is an edge adjacency of x dot pushback, and reverse adjacency of y dot pushback, the x. Okay, after this we have the graph. Let's calculate a DFS to get my ordering vector. DFS on 1 on any node. Okay, this might be, it might be possible. Let's go to each node. If it's not visited, then this is not visited. Create a DFS from. I think if that's the case, if there is two island only, then there won't be. No, this is connected. This is a directed graph. We cannot be sure. So if it is not visited, then perform a DFS from here. Pass the ordering vector also. After this, we will have the order. So I think we need. Okay, let's write the DFS first. DFS node and u and the vector of integer. So let's visit the node. We would need the visited vector also. Nothing is visited easily, so if it is not visit the node, go to all the neighbors in the forward graph. Go to all the neighbors of view and run a DFS. Pass the ordering. Once this is over, then we can ordering dot push back for p the u. So this will give me the ordering vector, right? Okay, we need to check if it is not visited, then we go. If it is not visited, then only go apply the DFS on v by passing the ordering and ordering dot push back q. After this, we will have the order, the topological order. We have the reverse graph. So one was added in the last. I think we need to reverse it. Yeah. Ordering. So we need to reverse the graph and go to all the nodes. Go to all the nodes. If that is not okay, we need to reset the visited. If that node is not visited, we can what is the component number? I think we need to okay, every node is unvisited. Again, visited of I is false. So reverse the ordering and go to every node and mark it as unvisited, and go here. If it is not visited, DFS on I, and how many components are there, how many strongly connected components are there. Yeah, it will work on the reverse graph. Would it be better to pass the adjacency also? No, we don't need the ordering in the second one. So okay, void dfs2 and u on this, we can mark it as visited. Go to every node. If it is not visited, but we need to go to the reverse adjacency. If it is not visited, go to v. Don't pass ordering here. It is dfs2. Okay, so mark it as visited. Go to every node in the reverse adjacency. If it is not visited, okay, that means we will also need what is the component. Yeah, that no need to pass here. We don't need to write for every node to which component that node belongs to. So we can just That means if it is not visited, that means component has increased, component has become 1. Now let's see what will be the answer. That means if everything is 1, the number of components should be equal to 1. So return 0. See out what, and the number of components is 1. If it is 1, then yes, otherwise it is no. Okay, would it work? Let's read the question. If the routes and no otherwise, in the latter also print 2 cities. Okay, in the latter case also print the 2 cities A and B such that you cannot travel from city A to city B. You can print any of them. Okay, we need to print it also. So if it is not possible, then no. Otherwise, okay, if it is not possible, then no, and print any 2 cities which cannot be visited, from where you cannot. I think that's easy, right? So we can have 2. So u is 0, v is 0. So first time DFA. So here the component is 0. That means first time I'm hitting this. That means that node becomes I. That component is 1. That means we can say v is equal to I. So if it is no, that means, okay, so answer is the number of component is equal to 1. Is it 1? So yes, otherwise no. So the answer is equal to yes, answer is equal to no. We can see out the answer, and we can also see out those nodes, which nodes, u as well as v. Answer is no, yes, and see out the, so we can cut it out here. Answer is equal to component is 1. So if component is 1, then it is yes, otherwise no. Only one component, and see out that answer whether it is yes or no. If answer is no, then also see out that u and v, and return 0. Let's see is it correct or not. We have an m. We read all the edges forward, x to y, y to x, get the ordering. Okay, so if it is not visited, DFS I ordering. Okay, what is DFS doing? Mark it as visited, go to all the nodes, go to all the unvisited nodes, and when it's over for you, we can push it here. Okay, after this we have ordering, but in reverse order, right? So because 1 will be visited in the last, we need to reverse that, so that we have, and then go in that order only. So for every node I, make it as false. Now go to, now for int I over the ordering, right? So in this order only we will apply the DFS. So number of components is 0. Let's see initially, number of strongly connected components is 0, and u is, let's let's say it is 1 initially, because it will, if n is at least 1, then yeah, then there will be at least one strongly connected component. If the graph is possible, then only. So u is equal to 0, v is equal to 0. That means those nodes, imaginary nodes, go to ordering. If it is not visited, yeah, it is not visited, then only we will apply a DFS2 and component will increase. So if component is 1, that means first time I'm visiting. So if it is not visited and component is 1, connected component is 1, that node is equal to I. Make it as 2 and DFS, apply the DFS on that. So after this, what will happen? Component will already be increased and become 2, right? So even if there was one component, so that will mark as 2. So that will increase. I think it is better if we write it here. So 0, 1, or let's write it here. So what does this mean? If it is not visited, that means component plus plus. Component plus plus. If component is 1, then u is I. If component is 2, then v is I. DFS 2 on I. Component plus plus, if component is 1, u equal to I. So let's increase it. That means I have got one component. It is the first time I'm visiting that, then u apply the DFS. Now after this, what will happen if all the nodes are not visited and I have one more strongly connected component? It will increase it to 2 and write that node and go and call the DFS on that 2. Okay, that means finally, if there is only one connected component, that means ideally they should visit all those nodes, right? That means component should be 1. Yeah, let's see, I think this will work. So what answer is, what component is 1? Yes, no. See out that answer, and if it is no, then we need to print u and v also. Okay, let's see. No compilation error, please. Okay, let's try. Okay, it did not work. Why am not? Does it need to be in sorted order or what? In the letter case also print two circles A and B such that you cannot travel from city A to B. If there is several possibilities, you can print any of them. Okay, that means here it should be V, it should be U. Why? Because in that graph, let's First test and then think. Printing V then U. Yeah, worked. So he has asked if there is a flight from city A to B, then we need to print A and B. So in my case, what was wrong? Let's think what was wrong earlier. So if this was the original graph, then I was printing. So I'm doing the so I got the order in this format, right? So U will be 1, V will be 2. From here I got U is 1, V is 2. So I have this graph 1, 2, 3, 4, 5. Obviously there is a flight, there are 2 nodes. So if what is asking, if the later case also print two circles A and B, so that you cannot travel from city A to city B. If there are several possible sources, you can print any of them. Yeah, I was printing 1 and 2, but it is possible to travel from 1 to 2, but it is not possible to travel from 2 to 1. So if it is a strongly connected component, let's say this, then the first node here, this is not the first node. So this is the first node. Let's say DFS started here. Then in my second one, right? So U was this node and V was this node. So I was printing U then V. That's why it was wrong. I should print V then U, because it is not possible to move from V to U, right? It is not possible, but it is possible from U to V. Yeah, got it. Why it was incorrect. Great.